Hi, it's Mitch Young, and today I want to talk to you about the Boxplots as a means of displaying the five-number summary for a distribution of quantitative values. As its name suggests, the five-number summary is a listing of five numbers. We have the minimum, followed by Q1, then the median, then Q3, and then the maximum. The minimum is literally the smallest value in the distribution. Q1 represents the value of the 25th percentile, where 25% of all of the values are either equal to that value or smaller than that value. More simply, it is the median or the middle of the lower half of the distribution. The median is the 50th percentile, so it is the number that literally splits the distribution half and half, so that 50% of the values are lower than this number and 50% of the values are above this number. So it is the middle number of the distribution. Q3 is the 75th percentile. It is the number that separates the lower 75% from the upper 75%. And you can think of it as the median or the middle of the upper half of the distribution. And lastly, we have the maximum, which is the largest value in the distribution itself. Now, Boxplots are the graph that we use to help display the five-number summary. So let's take a look at an example. In class, students guessed how old my mother was. And what you see before you is a listing of ages that were given as guesses. I have arranged them in order for simplicity so that we can easily find the information that we need. Now, the minimum value, I think that one is fairly straightforward. We can see here that the minimum is 57, so that will be the first number in our five-number summary. And we can also easily see that the maximum or the highest value is 80. Now, for the median, we will need to find the number that is in the middle, the number that separates the lower half of the values in the distribution from the upper half. Now, some students accomplish this by simply striking through some values and until they get to the middle. So if I strike through 57, 80, one from the left, one from the right, 62, 80, 64, 76, 66, 75, 67, 74, 68 and 72, 70 and 71, and then 70 and 70. So it looks like we have an even number of values, which means right here between these two 70s, I will find my median. As a matter of fact, it's exactly halfway between. And if I count the numbers to the left, 1, 2, 3, 4, 5, 6, 7, 8, and then those to the right, 1, 2, 3, 4, 5, 6, 7, 8, the number that's here will represent the median. Now, if there are two numbers in the middle, as we have here with our 70s, then we take the average of the two, and we're lucky to find that the average of 70 and 70 is 70. So this is our median, and that is a value that we will use for the five-number summary. Now, let's clear some of these things away. When we look at the lower half, now we want to find the median of the lower half, which will lead us to Q1, which is, sorry about that, which is the 25th percentile. So I would count 1, 2, 3, 4, 5, 6, 7, and 8. And from there, I want to be able to mark off again. But this time, I'm just going to draw a line where this would show up. So there would be 4 values to the left and 4 values to the right. So that split is here. And I need the average of 66 and 67 since there are two numbers in the middle. Remember, we put a place here for median. So that's 4 numbers to the left, 4 numbers to the right. So this would be Q1. And the average of 66 and 67 is 66.5. Then I'll go on the upper half and we'll get rid of these strike throughs so that we can see the numbers more clearly. And I'll draw a line to represent the median of the upper half, which is Q3, so 1, 2, 3, 4 to the left of this line, and 1, 2, 3, 4 values to the right of this line. Since there is not a single value in the middle, I need the average of 74 and 75 to represent Q3, and that number is 74.5. So these are the values that I will use in my 5-number summary. And so as you can see here, our 5-number summary is 57, 66.5, 70, 74.5, and 80. There's only one more thing we need to look at before we make our box plot, and that is to check for outliers. We have a numerical rule for outliers, and it is called the 1.5 IQR rule. That rule allows us to use the interquartile range, which is the middle range, instead of using the entire range, because sometimes there are values that are really small or really high that might throw the range off. So IQR is the value obtained by subtracting Q3 and Q1, and it does represent the spread of the middle 50% of the data. Now, any value that is less than Q1 minus 1.5 times the IQR, or greater than Q3 plus 1.5 times the IQR, is considered an outlier. So let's take a look at the values that we have again for your guesses of my mom's age and see if there were any outliers. So again, we see the 5-number summary. We want to find the IQR, and IQR again is the value of Q3 minus Q1. And so we are subtracting 74.5 minus 66.5, which gives us an IQR of 8. So the middle range, or the middle spread of your guesses, is about 8 years. Now if I were to multiply that by 1.5, so 1.5 times the IQR, then we get 12, which is 8 times 1.5. If I now subtract 12 from Q1, so Q1 minus 12, is that 66.5 minus 12, and we get 54.5. And then if I were to add 12 to Q3, which would be the 74.5 plus 12, then I get 86.5. And these are going to be the boundaries that help us determine whether or not we have outliers. So as we go and we look at our minimum is 57. Well, that's greater than Q1 minus 12, so no outlier on the upper end. And if I look at the maximum, that's 80, and our upper boundary is 85.5. So it looks like I'm well within my boundaries, so there are no outliers in the distribution of your guesses. So then we can begin to make our box plot. Okay, here we go. So I have scaled out an axis. For box plots, we only need the horizontal axis. There is no vertical axis as we are not counting frequencies. Make sure that your axis is scaled appropriately and that you're going in even increments as you move from number to number. And so now what I'll do is just start to draw some vertical lines to represent the outline of our box. The first vertical line represents the minimum value, which is 57, and I'm just going to estimate where 57 would be, about here. The next vertical line would represent Q1, which is 66.5. So again, just estimating where that would be. Then I have 70 as my median. 74.5 is Q3. And 80 as my maximum. Now, the box itself joins those 3 middle lines together. The minimum and the maximum serve as whiskers in this case. So I'll just draw a line from those vertical lines to the box itself, and now I have a box plot. Now, if there were outliers, I would treat this a little differently, and we will show an example of that tomorrow in class. So review this as often as need be. Also pay attention to section 1.3 and practice some problems with box plots. Tomorrow we'll look at the modified box plot in detail, as well as how to do this on the calculator, and then we'll get into written descriptions. Until then, have a good time.